Hello dear class 9 students, I hope everyone is doing well. So welcome to lecture number 6 of the chapter Structure of the Atom. So guys, here we will discuss about isotopes and their application. Now the chlorine isotope, this is the first isotope of chlorine, has a mass of 35 U and its abundance or proportion in nature is 75%. So the first isotope of chlorine has a mass of 35 U and its proportion in nature is 75%. Then the chlorine isotope, this is the second isotope of chlorine, which has a mass of 37 U and its abundance or proportion in nature is 25%. Alright, now see the average atomic mass of chlorine atom on the basis of above data. Okay, now let's solve it. So after doing the calculation, we got this value 35.5 U. So this is a fractional mass, and this does not mean that any one atom of chlorine has a fractional mass of 35.5 U. So this value, it does not mean that any one atom of the chlorine has a fractional mass. It means that if you take a certain amount of chlorine, it will contain both isotopes of chlorine and the average mass is 35.5 U. But this means that only if we take a certain amount of chlorine, it will contain both isotopes and the average mass is 35.5 U. Next, see, bromine occurs in nature mainly in the form of two isotopes. If the abundance of the first isotope is 49.7% and that of the second isotope is 50.3%, then calculate the average atomic mass of bromine. Okay, so now we have to calculate the average atomic mass of bromine. Now let's solve it. We know that upper digit in the symbol of an isotope represents its mass, which is same as its mass number. Now the mass of, so this is the first isotope of bromine, is 79 U and its abundance is 49.7%. And the mass of, this is the second isotope of bromine, is 81 U and its abundance is 50.3%. Okay guys, now do the calculation. So we got the mass 80 U and this is the average atomic mass of bromine. Alright. Let us see the applications of radioactive isotopes. So first we will see in case of uranium. Uranium has mass 235 and it is used for nuclear fission and production of energy. Now see, this is a nuclear power plant. So uranium is used as a fuel in nuclear power plant. Isotopes of some elements are used in the medical treatment of deadly disease like cancer. So isotopes of some elements, they are used in the treatment of deadly disease like cancer. Next, iodine, which has mass 131 and it is used in the treatment of goiter, a disease of thyroid gland. So when there is a deficiency of iodine in the body, we suffer from goiter, a disease of thyroid gland. Then radioactive isotopes are used in industry to detect the leakage in underground oil pipelines, gas pipelines and water pipe. So these radioactive isotopes, they are used in the industries which can detect the leakage in underground oil pipelines, gas pipelines and water pipe. Next we will see isobars. So let us consider two elements. Now see the definition of isobars. Atoms of different elements having different atomic number but the same atomic mass number. So isobars, they have different atomic number but the same atomic mass number. Now consider two elements, argon and calcium. So argon has 18 protons and calcium has 20 protons. There are 22 neutrons in argon and 20 neutrons in calcium. Now the mass number of argon is 40 and the mass number of calcium is also 40. So from here we can see that both the mass numbers are same, that is 40. Which two of the following atomic species are isotopes of each other and which two are isobars? So out of the four options, we have to find out which two of the following are isotopes and which two are isobars. Now let's solve it. The isotopes of an element have the same atomic number but different mass numbers. So we know that isotopes of an element, they have same atomic number and different mass numbers. The lower figure in the above given symbols indicate the atomic numbers. As you can see here, the lower figure it indicates the atomic numbers. Now in this case, there are two atoms having the same atomic number of 90. Can you see it? So the two isotopes will be these two. Now see, for finding out the isobars have different atomic numbers but same mass numbers. The upper figures in the given symbols indicate the mass numbers. In this case, there are two mass number of 230. So see, in case of isobars, they have different atomic numbers but same mass numbers, and the upper figures in the given symbols, they indicate the mass numbers. So from the four options we can see that there are two mass number of 230. So these two are the isobars. Okay students, I hope everyone is clear. Thank you.